Hello everyone. Hope you are all right. We have learned that an electric current flowing through a conductor produces a magnetic field. By various activities, we have learned this. And the field which is produced that exerts a force on a magnet placed in the vicinity of the conductor. Vicinity means the area near a particular place. Here we have vicinity of the conductor, which means the area near the conductor. And we know that the magnetic field produce that exerts a force on a magnet which is placed in the area near the conductor. So now in this session we will learn force on a current carrying conductor in a magnetic field. A French scientist named Henri Marie Ampere suggested that the magnet must also exert an equal and opposite force on the current carrying conductor. Who has suggested this? The French scientist named Henri Marie Ampere. Students, recall that in chapter number 12 we have learnt about electric current and the unit of electric current, which is ampere. It is on the name after this French scientist Henri Marie Ampere. He suggested that the magnets must also exert an equal and opposite force on the current carrying conductor. So let us understand an activity for this. For this activity, we will require a small aluminium rod length about 5 centimeter. We will also need a horseshoe magnet, then a battery, also a rheostat, which is a variable resistance. We will need a key also and some connecting wires. Then we have to arrange all these apparatus as shown in the figure. We have this aluminium rod. We'll say it as AB, which is 5 centimeter in length. Then using two connecting wires, we have to suspend it horizontally from a stand as shown in figure. So two wires we will take and that will suspend horizontally. Okay. Now, how do we have to keep horseshoe magnet? We have to place it in such a way that the rod lies between two poles with the magnetic field directed upwards. So now this horseshoe magnet will keep in such a way that the aluminium rod lies between two poles of this magnet. And it is also said that so that the magnetic field directs upwards. For doing this, how will we keep the magnet? In such a way that the north pole of the magnet that will be vertically downwards and the south pole should be vertically upwards. Okay, look at the figure. The north pole is downwards and south pole is upwards. Then we have to connect the aluminium rod in series with a battery and a key and a rheostat. The ends of this aluminium rod will connect with a battery, key and a rheostat. Then we have to pass a current through the aluminium rod from which end? From end B to end A. Now for doing this, how do we place battery? So that the current will pass from B. We know that the current passes from positive terminal, right? So we'll keep in such a way that the positive end of the battery that is connected with B end of the road, so that the current passes through from B end to A end. And when we pass the current, we need to observe. You will see that the road is displaced towards the left. When we pass electricity, the rod, aluminum rod, is displaced. It has moved towards which side? Towards left. It is shown in the figure with blue arrow, a little blue arrow, so that it has moved, displaced towards the left. And it will be observed that the road gets displaced from its place. Then in the next case, reverse the direction of current flowing through the rod, which means what do we do? Now we will join the positive terminal of the battery to the end A of the aluminum rod, so that the current will pass from end A to end B of the aluminum rod. And then again, if we pass electricity, what will be observation? Will the aluminum rod get displaced? Of course, yes. What will be its direction then? The direction will also be reversed, which means the aluminum rod will displace toward which direction? Towards right direction. Okay. Now we have seen that the aluminum rod displaces in this activity. What does it tell us? The displacement of the aluminum rod in the above activity suggests that a force is exerted on the current carrying aluminum rod when it is placed in a magnetic field. Students, till now we have learned the cases where we pass electricity through a conductor and then we observe that magnetic field is produced. Now here, what are we learning? That we have placed aluminum rod in a magnetic field in between two poles of magnet. So we can say that we have placed that aluminum rod in a magnetic field. And now what are we observing? That a force is exerted on the aluminum rod, which means we are learning force on a current carrying conductor in a magnetic field. When we place any material in magnetic field in between magnets, then there will be force exerted on that material. Here we have aluminum rod. So we have seen that it is displaced. When it can be get displaced? When there is any force exerting on it. We have also seen from this activity that the direction of force is reversed when the direction of current through the conductor is reversed. Now, change the direction of the field to vertically downwards by interchanging the two poles of the magnet. Till now, we have seen the observation for direction of magnetic field when current is passed to different ends. First, we have seen when the current is passed from B end to A end. In second case, we have seen that when the current is passed from A to B. Now what are we going to do? We will interchange the poles of the magnet. which means till now the position of the magnet was in such a way that the south pole was vertically upwards and north pole was vertically downwards. Now we'll change the poles, which means we'll place it in such a way that the north pole will be vertically upwards and the south pole will be vertically downwards, and the current will be from B to A. So in this case also, when we reverse the poles, then again the direction of magnetic field will also be reversed. If we take another case that north pole is vertically upwards, south pole is vertically downwards, and we pass current from A to B. Again, the direction of the magnetic field will get reversed. What does this mean? In each case, we are seeing that the direction of the field keeps changing. This shows that the direction of the force on the conductor depends upon the direction of two things: current and the direction of magnetic field. Please keep this statement in mind very well. What it is? The direction of the force. Which force? The force which is exerted on the conductor. What is conductor here? Aluminium rod. So the direction of the force on the conductor, that depends upon two things. One, the direction of current, and another, the direction of the magnetic field. Different experiments have shown that the displacement of the rod is largest, or the magnitude of the force is highest, when the direction of current is at right angles to the direction of the magnetic field. What does it mean? The displacement of the rod is largest, maximum. Magnitude of the force is highest. Displacement of the rod is how much the rod is moved from its place, right? So when it is like that, that the displacement of the rod is highest or the magnitude of force is highest. Now it is simple thing that when an aluminium rod displaces more, when can it get displaced more? When there is more force, right? If the force will be highest, it will displace more. Simple, right? So when this can happen? It can happen when the direction of current is at right angles to the direction of magnetic field. Please remember this. When the direction of current is at right angles, what does that mean? Perpendicular. Okay. When the direction of current is perpendicular to the direction of magnetic field, then only the displacement of the rod is highest, which means the force exerted is highest, maximum. Okay, students, so please remember this, that through different experiments, it is the statement that the displacement of the rod is largest, which means the force is highest when the direction of current is at right angle, which means perpendicular to the direction of magnetic field. And how do we find the direction of the force? Let us learn one rule for it.